Let's do this. Okay, so the first thing I wanted to mention to you, which is not something that's going to be necessarily on the SAT, but it's a word that you want to be familiar with. It's going to help you understand this, and that word is called residuals. Okay? So every time that we look at a linear regression model, okay, so basically, again, what the computer will do is based on your scatter plot, it will predict a line that best fits this data. Okay, so if you take stats, I'm going to go into more detail, or in college you go into more detail about how to make them yourself and how to use technology to make them. On the SAT, they already make them for you. All right, so really the SAT is about understanding how to use them. Okay, so a residual. A residual is always the actual value that you observed. All right, so it's the observed Y value that actually happened. Okay, minus what the model predicts should have happened. All right, so that difference of what actually happened minus what the model predicts should have happened is called a residual. All right, and the reason I bring this up is because it's really cool. The computer will actually, in a split second, all right, it'll calculate this line. All right, but what it's doing is it's looking at the residuals for every single point, and it's trying to minimize that distance, right? It's trying to take this subtraction and get the smallest possible number for each one. All right, and it does it like that, on a snap of your fingers, but that's what it's doing. Okay? All right. So, a couple of ways that you'll see it read is the line of best fit, the least squares line, right? These all mean the same thing. And basically, the reason I'm bringing this up is because whenever I'm talking about a linear regression model, you're going to see, all right, sometimes in reading these questions, they mention the line of best fit or the least squares regression model. Okay, so all these things mean the same thing. All right? Now, let me show you what it actually is. And you're going to be very excited about this because it's just like what you did in Algebra 1. Okay? You guys see the model here? All right, it's in slope-intercept form. All right, so all that work you did in Algebra 1 is going to pay off when you get these questions on the SAT. Okay, so here's an example down here. You can see the blue dots in the scatter plot. And if you see the red line, that is our least squares regression line. So what that red line is it's tried to minimize all of the distances of the blue dots to the red line. Okay? So again, the computer is drawing millions of lines instantaneously, and they landed on this one because it has found this one to be the smallest distance when you look at that distance between the blue dots and the red line. Okay, and again, you don't really need to know that, all right? But I'm just showing you what it means. Now, you'll notice this hat on top here. Again, that's also not going to be on the SAT. That's more statistics. That hat just means predicted. All right, so basically, whenever you calculate a Y hat, you're just saying, this didn't actually happen. Here's what the model thinks should have happened. All right, so it's just a prediction. All right, now, you guys know from your days in Algebra 1 that M is the slope and B is the Y-intercept. All right, so that's not going anywhere. All right, so hopefully you're extremely confident with Y equals MX plus B. Okay? Awesome. Okay, so now let me show you what it looks like for the SAT. So go and flip over. Because this example we're going to do, what I did was I found all the ways that the SAT is going to ask you about linear regression, and I put it all into one problem. All right? So we're going to practice, obviously, more iterations of this, but I wanted to take one problem, which I do with my stats kids. I do this problem with my seniors, okay? But I obviously do a little differently, like they have to make all the stuff, okay? You don't have to, because this is talking about the SAT. Okay, so we've got several used Toyota Corollas that are for sale. Okay, so you can see the first variable is how old they are, so age. So 1 year old, so that's fairly new, all the way to 13 years old. Okay, and then this is the price that they are listing to sell it at. Okay, so what I decided when I made this scatter plot is that the age of the car, so how old it is, explains the price. So the age explains the price. So when I made the scatter plot, I put age on the x-axis. So I know it's kind of hard to see with the actual line there, the model, but you guys see the green dots? So think back to Wednesday. Do you remember the three things we had to describe when we look at a scatter plot? One more. I mean, it is for the form would be linear or not linear. There's one more word. Okay, what's that called? Positive and negatives, right?
Direction.
Excellent, right? Think of your favorite band. One Direction, okay? So, direction, form, and strength. Now, take a look. I know, try to ignore the black line for now, okay, because that's the model. But look at the green dots. All right, I think we'd all agree that this is negative. All right, do we think it's linear? Looks fairly linear. All right, and then what about strength? I actually think it's strong. See how they're really tight? Right? I know there's space, but you see how all the dots are really close together? There's not some here all the way over. Look how close they are to the line as well. Yes?
When telling if it's strong or weak, doesn't matter what much less the dots how close
It matters the scatter, not how many dots there are. Sometimes it's hard to differentiate between the two, but it's more about how tight they are, the scatter. Okay? Now, again, I'm not worried about the strong, weak, moderate. I'm not worried about that, okay? You're going to be fine. So, for this, all right, this is our model. All right, you'll notice it's in slope-intercept form. So this is our slope here, all right, and our y-intercept. Now, on the SAT, the most common way they ask you questions about linear regression is to interpret the slope and the y-intercept. Okay, so it's going to take some practice. All right, so we already described the association. I'll go back to that. I want to do this right now. Interpret the slope. Okay, so I'm going to write it down with no context. Okay, so I'm going to write it down first with no context. So for each additional unit of x, the y value changes by the slope. Okay? So what my seniors know is that for every unit that you add on, all right, for the x, that the slope is going to tell you how much the y changes. All right? So you'll notice that's the answer, but it has nothing to do with the cars, right? So this is called no context. So on the SAT, you're going to have to answer it in the context of the problem. All right, so let's think about this. Go back to the scatter plot. What is the x variable? Age, okay? So what would be an additional unit of age? 1 year, right? Because we're talking about age in years. So you write this is what you write. So for each additional year, what do I expect to happen to the y value, which is the price? What do I expect to happen to the y value, which is the price? Katya? Decrease by how much? That number, right? That's called the slope. That's what the slope means. All right? So for each additional year, I expect the price of a used Corolla to go down by $959.05. Okay. So that's what you have to memorize for the SATs. I guarantee you, really the second part, Jonathan, right? This part here, because that's context. I wrote the first part so you can see what it means when there's no context. Okay? But I guarantee you'll have a question like this on the SAT in March. Guaranteed. Okay? It was so prevalent. Every time I looked at an SAT section, there was always a question about slope. Okay? At least one, probably more. Okay? And we're going to practice all the time, right? You're going to do a bunch of these. Everybody good? All right? Even if you're not good, just know you're going to practice a ton. All right? So that's what it means to interpret the slope. Yes? We're going to practice. Yeah, I mean, we're practice until we take the quiz. Okay. Now, the Y-intercept. Let me write for you the Y-intercept with no context, okay? So the Y-intercept means that for an X value of 0, our Y is the Y-intercept. Okay, so I'll say it again. If you have 0 units of X, then your Y value is the Y-intercept. So that's, again, no context. Okay? So now let's try to bring it back to this problem. So this problem, what is X again? X is the age, right? So how old the car is. So what would be 0 units for that? What would be 0 units for X? 0 of these units. Be 0 years old. Well, what do we call a car that's 0 years old? Brand new. So what we're saying here is that if you have a 0-year-old car, a brand new car, we expect the price, the Y value, the price, to be the Y-intercept, this number here. Okay? So that's what we're going to write. We expect, I'm just getting a little out there, all right? We all of us collectively, we expect a brand new Corolla to cost $14,285.90. Now, after you write that down, what I always ask my seniors is like, is that true? Right? If I were to go look at a brand new Corolla in this scenario, will it cost exactly that much money? Probably not, right? So that's why we use that phrase, we or I expect, because we know deep down it's not going to be exactly that, but we're expecting something around here. So if a brand new Corolla, it's costing us $19,000, I'm like, whoa, that's way higher than I thought. All right? Or if they're saying a brand new Corolla is only going to cost you $10,000, well, that's way lower than I thought. But if they say it's going to cost you $15,000, that's fairly close. Okay? So just keep that in the back of your mind. I'm not saying it's going to always be these numbers. That's just what we expect to happen based on the model, right? Based on the model. Okay, how's everyone doing? Everyone okay? Okay, let's keep going. All right, so these are some other ways that the SAT is going to ask you questions about a linear model. Okay, so it says, if you want to sell a 7-year-old Corolla, so you're talking about your car is 7 years old, what price seems appropriate? All right, so this is asking you to take the model, all right, and to plug in how old your car is to the model. And the model will spit out what price is appropriate. So I'm going to write down the model again. Y equals negative 959.05x. Is that right? Yes, so far? Okay. Plus 14,285.90, right? Okay. So, yes, Jennifer. Yeah, yes. Well, hold on. You mean like, will it tell you the formula? Yes, they'll give you the model. All right. You have to interpret the Y-intercept. Okay, so what am I plugging in for X? Remember, that's age. How old is my car? 7 years old. So I'm going to plug in 7 for X. So Y equals negative 959.05 times 7 plus 14,285.90. And now you would take out your calculator. So if you don't have one, go get one. And you're just going to plug it in. Do the algebra. Daniel, did you get a number? What'd you get? 7,572.55. Anyone concur? Yes, people got the same thing. All right, let me write that down. $7,572.55. Okay, now, if we were actually going to use this model, right? So just imagine we're going to go sell this car, or at least put a for sale sign like in the window. Am I going to write that number on the for sale sign? Probably not, right? I'm probably going to write something close to this, maybe like 7,600, all right? Or if I think I can make $1, 7,700, right? Yeah, I'm trying to make money here. I'm trying to sell my car. So what we're just saying is that the model thinks it should be priced at this number. How you want to price it is up to you. Okay? Everybody good with that? So that's just an example of using the model to get a predicted Y value. Okay. Letter E. What year was the Corolla if it sold for about $5,500? Okay? Now, there's a couple ways to do this. We're going to do it first algebraically. In this problem, we're solving for the year. And what variable is the year? X. All right, so I'm going to be solving for X. But this value of $5,500 is my predicted value for being sold at that. So that's going to replace Y. Because I'm solving for how many years old the car would be to get that number. Okay, so now it just becomes something you would have done in Algebra 1, where we're going to move over the Y-intercept first by subtracting. Okay, so I know I have negative 959.05x over here. Let's see what I got on the other side. Okay, on that side I've got negative $8,000, $785.90. Okay, now how do I get rid of that negative 959.05? You divide, very good. All right, so when we type that in, I know it's going to become a positive. And I got 9.2 years. Okay, so when it says best guess, about how old was this Corolla? That's closest to 9 years. So I would write it's about 9 years old. Okay, now there's actually a way to do this using the scatter plot where the model is. So once you guys finish writing this down, I'm going to go up to try to look at the graphical display, the scatter plot, see if I can eyeball it to see where this is. Okay? All right, so you guys ready to take a look at the scatter plot? All right, if you look at the scatter plot, zoom as far as I can. All right, it says what amount of money was this Corolla sold for? $5,500. So that's like just barely over that 5,000 number, right? So if I just imagine, you can eyeball it or draw it. Thanks, Jonathan. Okay, so I went about here, and then if I go down from there, right, that's around what? Around 9. Maybe in this case, it kind of looks like a little shy of 9. So obviously, it wasn't drawing a perfectly straight line, right? The idea here is that you can eyeball it and see your best guess would be about 9 years. I would probably even accept 8 or 10, okay? Because that's very close to that. Everybody good? Okay, so you can do it algebraically to get the exact answer, or you can just try to eyeball it. Okay, let's keep going. The last slide. Okay, for the Corolla that was 6 years old, all right, so a 6-year-old Corolla, the sale price was about how many dollars less than the price predicted by the line of best fit? So this question on the SAT, right, they're not going to give you the actual data, right? Remember the very first slide, I gave you how old, and the price, okay? So we could do this problem algebraically, but I want to practice doing this using the scatter plot because that's how it's going to be on the SAT, okay? So on the scatter plot, all right, we're looking at the car that was sold that's 6 years old, okay? So 6 years old is this dot right here. So I'm focused on this dot, okay? Everybody focusing on that dot. How far away is that dot from the line? All right, so if that is the line of best fit, and this is what it actually sold for, the model is predicting it should have sold for more. How much more? What do you guys think? Remember, here's the scale here, $5,000 to $10,000. So how much more here? What's that distance? What do you think? Just guess. How much? 2,000? Okay, anyone else? 1,000? That's what I put, 1,000. I'd probably accept 2,000, right? But again, you'll have answer choices, A, B, C, and D to look. All right, so I think the answer for this is about $1,000 less. Okay, so basically, I don't know who sold this Corolla, but according to the model, this person who sold this Corolla lost money, right? Because according to the model, they should have been able to sell this Corolla for about $1,000 more. Okay, good. Again, according to the model. Everybody good there? Okay, the very last one, letter G. What is the price in dollars of the used Corolla that was the oldest? Again, I know you can answer this question by looking at the table, but this question I put here is because on the SAT, they have you use a scatter plot. Okay, so we want to look for the used Corolla, that's the oldest, and what was the price? All right, so where is what green dot for me is the used Corolla, that's the oldest. The one at the far right, okay, and it's actually a 13-year-old Corolla. All right, so if you just look and try to draw a line over or eyeball it, what is that price? Right, that's what I put, 2,500 is what I put. Again, you can compare it. Oops, 2,500. What was the actual price if you look at the data values? 2,850, right? So we're off a little bit, okay? But again, this is practicing what you're going to do on the SAT, but you have to like line it up. All right? Yes, Lisa. So if you plug in 13 years, this is a really good question, Lisa. If you plug in 13 years, you're saying to the model, right? Okay, if you plug in 13, that's going to give you the price that is predicted they should have sold it. So that's a really good question. It's saying what is the actual price that it was sold for. But good question. If it had said what is the predicted price, then we'd be doing that. All right, good thought. Yeah, Jen.
So it doesn't matter if it's like on the dot, like.
You're looking at the dot, right?
No, I mean like no, like the answer, like it could be, because you know how you said it's 2,800.
Yeah. Well, so again, that's really because I can't eyeball it perfectly, right? So I'm just approximating. Are you asking about why the green dots are not on the black line? Because that's a really good question.
Does it matter if they're accurate?
No, because again, on the SAT, you won't have that table, right? We were able to check and find out, oh, we were wrong. On the SAT, you're going to have answer choices. So maybe the answer choices were 2,500, 3,000, 4,000, 5,000. I don't know, and you're trying to find the one that's closest to what you think it is. Okay? All right.